Welcome to long division of polynomials. This is a very interesting task, a little tough at times, so you have to attend to precision. So let's say I take a cubic polynomial and I divide it by a linear polynomial. So the first thing I'm going to do is I'm going to type f of x divided by g of x if I've defined both of them, and Desmos tells me the resulting graph is supposed to be a parabola. Let's see if we can get that to work. So long division works same way that long division with numbers works. I take 3x and I'm going to find out how many times it will go into 6x cubed. That would be a total of 2x squared times, because 2x squared times 3x is 6x cubed. All right. Just like with long division of numbers, I'm going to multiply after this step. So I get 6x squared plus, or 6x cubed, excuse me, plus 2x squared. All right. And if you remember, long division, you have to subtract now, right? 6x cubed minus 6x cubed is 0. 5x squared minus 2x squared is 3x squared. All right, pay attention because this is in parentheses, so you have to subtract it. All right, that's why my subtraction is outside. That's 5 minus 2, gives me 3. All right, I did not subtract anything from 19x and 6, so I have 19x plus 6. That's round number 1. Rinse and repeat. The steps are divide, multiply, subtract. 3x will go into 3x squared, a total of x times. All right. X times 3x gives me 3x squared, lines up. X times 1 gives me x, and I'm going to subtract that. I am left with 0, and 19 minus 1 is 18. So I have 18x plus 6. Last time, 3x will go into 18x how many times? 6 times. 6 times 3x is 18x. Nice. 6 times 1 is positive 6. And when you subtract that line, 18x plus 6 minus 18x plus 6, you get 0. All right. Showing you that this is indeed your quotient and that 3x plus 1 was a factor. All right. I'm going to check my work real quick by graphing that result. 2x squared plus x plus 6. Guess what? Same parabola. My result is correct. Now, let's move me a little bit right here, and you see the box right below my face. So let's move the box. Let's move me a little bit more. Do we have time for this? Sure we do. Let's think a little bit about factoring. So essentially, I'm trying to figure out how many times 3x plus 1 will go into 6x cubed plus 5x squared plus 19x plus 6. If I think about the box, right? If I were to, whatever I multiply 3x plus 1 by the other factor, I'm going to get 6x cubed right here, right? And I'm going to get a 6 right here. That's the way the box works. Leading coefficient, top left, y-intercept, bottom right. So I can really treat this like a puzzle. What do I multiply 3x by to get 6x cubed? Well, the answer is I multiply it by a 2 and an x squared. Matches up. Then I sort of let this fall into place because I've got a 2x squared and I've got a 1, and the rule is I got to multiply those, so I have a 2x squared here as well. Now this is where you want to pay attention. That's a 2x squared. How many x squareds did my cubic polynomial have? Well, if you check it, I'm supposed to have 5x squareds. So that means I need to combine 2x squared with this box to get 5x squared. Well, that would mean that this is missing a 3x squared. Now that combines to be 5x squared. Let it fall into piece again. 3x times what gives me 3x squared? Well, that would be an x. X times 3x gives you 3x squared. Still checking out. X times 1 would give me x. I have to multiply those. That's the rule. And then I'm in the same conundrum again. How many x's would I need right here to line up in the diagonal? Well, I have a total of 19 x's. That means I'm missing 18 x's right here. All right. I think, okay, 3x times what gives me 18x? Well, that would have to be 6. And then I double check. 6 times 1 gives me 6. So you see, I got the same quadratic factor, 2x squared plus x plus 6. That quadratic factor is the same whether I do long division or a factoring by the box, by working backwards. These are sort of the same concept. You can see some of the same numbers, and you get the same result, which you have verified with Desmos. That's your introduction to division. Very good.